Hello and welcome to another video from Ellensburg Amplifier Repair and Service. My name's Todd, and today we have a JL Audio 500/1. This is the revision 11 board that Tom Ting has patiently been waiting on. It had a burnt, shorted inductor with a couple capacitors that were burnt. So I decided today I would just make a video on this board, some of the right ways to do things and some of the wrong ways to do things, and also some things to look out for. So first I want to start with the original fault of this amplifier. So this is the original inductor that came out of it, and you can see how the plastic has melted right around the middle of the inductor. And while this inductor is together, just kind of give you, I don't know if I can get it back together. This inductor has an air gap core. So as this inductor heats up and starts to get really hot, I mean really hot, you will notice the inside of this inductor, the plastic has actually started to melt and form the gap in between the inductor. Sorry, as my autofocus there keeps going in and out on you. I'm trying to do multiple views here. So the first thing is if you see this kind of melted, shorted inductor, is to replace the inductor, because this will be shorted. It shows as a direct short on my meters. And a good inductor will show, at least on my meter here on my MK328, it'll show a 0.06 millihenry. So this is a good inductor. This is the way it should look. Bad inductor. And I scoured all my local people here for a revision 10, revision 11 board that had these same inductors. And one of the most common things that I found is these inductors are shorted. So for you JL guys, if you have an amplifier that is not starting properly, I would check your inductors. And also there are some capacitors too that short out. So things you just want to keep an eye on. And what I'm doing right now is I'm kind of digging the insulation from the inductor to kind of show you what happens to these. So, whoops, sorry about that. Let me see if I can switch views here. So the inductors, there's a small cardboard layer, paper layer underneath the plastic. And what's this focusing into here? There we go. And what happens is these windings will get so hot the lacquer on it will deteriorate, and these windings will short together right here. And that is the problem with these boards most of the time, is your inductors. So this overloaded the amplifier and took out, as you can see, took out the power supply on the amplifier. All right, here's your power supply. Took out the power supply. This particular revision 11 board used through-hole resistors for the gate resistors, which is really nice, but the vias on these are so small that the solder, when you cook solder to a point like this, it really becomes a nightmare to remove out of the vias. But I got all the vias cleared, ready for new resistors. This board used the IRZ44N transistors, and I'm going to be switching it to the 3205s with 47 ohm gate resistors. And one of the things that I wanted to show you guys about the jail audio transistors, and one of their weak points is the way the board is situated versus the legs of the transistor. So you want to bend your legs in a way that's right and not in a way that's wrong. So I'm going to show you two different transistors on the close-up, the best I can, of how to bend your legs on those transistors. I'm just going to show you the right and wrong version here first. So this transistor, you can see that the center leg, the drain, is at an angle coming out of the base of this transistor, while this one here is coming out nice and straight. And then of course you have your little offset on the center pin. You want to make sure that when you bend your legs, you don't apply any abnormal pressures to the pins coming right out of the base of the transistor. This will be a high failure area from vibration and thermal expansion and contractions of the amplifier. So you want to make sure you bend it straight. So now let me show you how I go about bending these legs properly. There's a good right way to do it and a good wrong way to do it. Again, you want those legs nice and straight. Let me get my autofocus here set up so you guys have a little bit better viewing. All right, so there, I got your guys' autofocus set so it doesn't quit going in and out of focus there for you. So this is a good one, and all transistors come with straight legs. So what I do is I just take my tweezers and I just gently slide the tweezer right in between the gate, drain, and source pins and bend that drain pin up while holding with my thumb the legs coming right out of the base of the transistor. And then I give it just a slight little turn. And that'll add that offset to that transistor without bending the pin coming out of the base of the transistor. It's nice and straight, flat. You want this offset right here. I've seen amplifiers come in where they'll take a transistor straight like this and slide it right into the board, which applies pressure to this joint right here on the drain, right at the base of the transistor. So when you get these JL amplifiers in for repair, sometimes what you're going to find is the transistor has broke off at the base. The pin is broke off at the base of the transistor. So I'm just going to go through and add my little curve to my transistor legs here, as you can see there. And this is how you want to situate the transistor in the board to limit returns. I warranty all my craftsmanship. I warranty the work that I perform. So I have very, very few returns. Most returns I get are from end user errors. So you'll see on my Facebook page, I just posted, at the time of this, I just posted a clip from Sundown Audio that released a video explaining how to hook up your subwoofers to a monoblock amplifier. So they did a great job explaining how to hook up to a monoblock amplifier, because a lot of people don't understand the final connected impedance of an amplifier. So I suggest looking into that. If you find that I'm repairing your amplifiers and you keep burning them up, well, there's a reason why they're burning up. So I do full load testing on all amplifiers. So when they leave my place, they have been tested, they have been thermal cycled. I don't drive these amplifiers up into full clipping and hold them there. That's I don't do that. That's if you want that done, you're more than likely a sound competition guy, and all that does is stresses the components. I look for durability. My key is durability and longevity of the amplifier. So with now all these transistor legs bent into proper shape, with no stress points, it's just time to put the gate resistors in. And I've already checked the drive on this board. I think this uses the SG3525 for the drive. I don't know. I'll admit, guys, I'm really bad about taking notes. I don't have a lot of things memorized. Amplifiers, for the most part, I can look at them, hook them up to a scope, get my digital multimeter out and tell you what's wrong with it, and tell you what it's going to take to fix it. That's how I work. I know a lot of people, they do ask me a lot of questions on particulars, and I have to go back through either schematics or notes, the small notes that I have taken about some particular amplifiers that should have notes, I should say. So then I'm just installing these resistors into the board. Of course, in the same direction. I'm a very meticulous person here when it comes to repairs. But I do have one via that's been giving me a problem. But never fear, we'll take care of it. So I'm just going to slide these resistors in. There it goes. It's best to do your resistors first. And there's a reason why I will do the resistors first, if I don't lose track. Because what you'll want to do is, if you're a meticulous kind of repair person, is you'll want to check your gate signals before you put your transistors in. Remember, the transistors are responsible for swinging that transformer, and without transistors you will have no rail voltage. You won't have any swinging of the transformer, I should say, because you can pull the rectifier out and fire the amplifier up and see if you have your switching signal through the transformer. But this is a regulated power supply. It gets messy, so I just like to verify that I have my drive signal present. Before I put my transistors in. And another good tip is on your gate resistors. If you were to pull your gate resistors up off the board, you will save a lot of headache time to the next person that's got to fix it, if it ever has to be fixed again. Because these resistors will get so hot, it'll burn the board. So, as you can see, what I do is I just bring the resistors down to where I want them, to the board. This just prevents future problems for the PCB itself carbonizing. because carbonized PCB is conductive. So you want to avoid burning the PCB. I do PCB repair. It is not cheap, but I do perform it. It does take quite a bit of time and resources to do, but I do PCB repair. So right now I'm just making sure all my resistors are lined up where I want them to be. There. So that's all the resistors lined up. They're still a little off just a little bit. Again, I am pretty meticulous, but once I place the board down, it'll all get pushed up into place. So I do raise those resistors up off the board. Then I just use my tweezers, line them all up. The Hacko FX888 is up and running. I'm just going to put just a little bit of flux right down at the vias, because again, these vias got pretty hot, so I want my solder to flow nicely through the via. Of course, again, the good old Amtech flux. And the Hacko iron. And I'm just going to reach right on down in here and just place some solder right at the legs of the resistor. Takes just a second to solder these. We'll get these soldered into place. And quick and easy. And then what I'm going to do is I'm just going to flip the board over. And as you can see, I've got all the pins laid out here, all the legs of those resistors. I'm going to go through and just double check to make sure that the vias are nicely soldered into place. That's probably my biggest gripe about JL audio boards, the vias. I don't mind working on JL audio, but their vias, they could use some work. And just like that, the vias are complete. We're gonna clip off the transistor. Keep calling these transistors. Sorry, guys. We're gonna clip off the resistor legs. And for all you guys that do JL board work, another good little tip is on your LED board on the back side, if you take some of your glue, which all you guys should have to be gluing down your components, your inductors, transformer, windings, is to put some glue right here to keep these wires in place. If you do a lot of flipping with your board, you'll end up breaking those wires off. Black is number one, and black is number 1 on the left-hand side, away from the incoming power terminals here. So pin 1 is on the left-hand side when you're looking at the board in this orientation. So got those resistors done. So let me just get a little Q-tip action going on here. Little Q-tip action. I like to make sure my work area is clean. Don't be bashful, guys, to clean your areas. Cleanliness is key to successful repairs. I'm actually working with a guy that I think he may have had a solder bridge on one of his transistors. So, you know, the biggest point is just to take it slow. Look over your work before you fire things up, because some of these voltage can get pretty high. And just like that, it looks like all the resistor legs are soldered through. Let's flip it back over. And clean up the flux from the resistors on the top end. Sometimes this flux can be slightly conductive. I noticed that early on in what I do when I was putting the IRS 21844 ICs on a Maxonics board, that I was getting some odd signals on it on the drive, but when I went through and cleaned up the flux around the pins, that odd signal disappeared. So this stuff, when not activated, heated up, will carry a signal. So you just want to make sure that your signals are as clean as possible when you're doing testing. Signals are important. The right frequencies are important. In proper amplifier operation. And just like that. Clean up this flux. All the resistors are stood up off the board to prevent future carbonization of the board. And we're going to hook up some power. So it's 12 volts on the outside. Ground is the center. Ground is the center. We'll have our little LED board here to show you what's going on. And let's get a scope going. Select, search, the USB scope, search, Rigol Technologies, select. And there's your scope. So let me just check and make sure that I have nothing conductive underneath the board. That's always key. You want to make sure you get all your conductive materials away from the bottom of the board. Make sure I have power. This is my 10 amp current limited supply. This will shut down pretty quick if there's any issue. So I like about these brick power supplies is they're pretty sensitive to overload, so they'll shut down pretty quick. And we'll fire it up. And as you can see, I got a little green light right there. No smoke is rising from the board, which is good. You don't want any smoke rising from the board. And typically at this point, nothing will heat up. So we're just going to go ahead and check a signal. Let me get the scope set up properly here for you guys. So there's your gate. Looks like we do have some overshoot on the gate. Try to zoom in on that overshoot there. So there's the overshoot on the gate, which isn't too bad. So we're at a 5-volt division, so you're about 2-volt overshoot on that gate signal. Which again, this is an unloaded gate after the 47 ohm resistor. But the primary thing is we have a gate drive. And the gate drive for this amplifier unloaded is 35.2 kilohertz. Again, remember this is a regulated supply. It doesn't have any feedback going on right now. So that SG3525 is just swinging those gates, basically waiting for some feedback to regulate that. So that's the gate drive. Green light, gate drive, nothing heats up, of course. So from here, we're good to install the output transistors. I'm just gonna disconnect my power here so I don't have anything really in my way. Well, the next thing about installing these are the proper height. So what I do is I use the original height of the output transistors, and I'm about 1/8 of an inch sticking out of the board for those transistors. So I'm just going to install these to about 1/8 of an inch sticking out the bottom side of the board. And if you bent these right, these should slide right on in with really no resistance. There's 8 power supply transistors. Get my measurement card here. The original output transistors. So use that as my guide. And I'm going to just tack the gate leg in place briefly, because the gate leg has the least amount of surface area. So it doesn't take as much heat away from you while you're trying to get these locked into place. So it's quite simple here. I just take my measurement card that I had put a line on. I'll hold that transistor in place. And solder that transistor at the right height. So again, I just use my card. That black line right there tells me where the top of that transistor is. Grab me some more solder here. And what I'll do is I'll just put some solder just on the tip of the iron, go to the next transistor, slide it up where it needs to be, and solder it in place. And we just move right on down the line. It's pretty quick, simple process. And then from there, I have a good idea of the height of these from its neighbor. Just like that. And then I'll double check the height. And this is because the heat sink uses those pesky clips. So you want to make sure that your transistors are the right height because it uses those pesky clips. Looking pretty good. Nice. All right, so I got all those transistors lined up. And now I'm going to turn the 888 off and turn on the FR 301 because I use the FR 301 to solder in the higher thermal mass areas. That scope's kind of in the way of the view there. So this is where we're going to be soldering right here. And again, I'm going to be adding some flux just to let the solder flow right down those pins to get a good contact into those vias. So then I'm just going to solder the drain and source. Go through and do the sources real quick here. Make sure things are looking straight. So by soldering that source, you can adjust how straight your transistor is. And we're looking pretty decent. And then we're going to go through and solder the drains. And last but not least, I'm going to finish up the bottom side of the gates. just to make sure they are fully soldered into place. And that is how you do your power supply transistors. And again, we go through, clean up the flux. Because from here, you need to double check and make sure you don't have any solder bridges across your gate drain source, because that will give you a bad day. Well, not really a bad day. It'll just you possibly can short out a transistor. You'll be replacing a transistor. So you just want to verify your gate drain source connections on the bottom where you did your soldering to make sure you don't have any solder bridges. You know, as they always said in construction, you know, measure twice, cut once. Well, this is solder once, double check twice before you put any power to it. And then what I'll do is I'll just take the real fine tip of my tweezer and just go right in between the gate drain source pads here, just to make sure nothing is in between. And just do one final round on the Q-tip. So I'm not going to cut the legs off quite yet, because you just never know when something is going to go south or haywire. There could be an issue in the output. I don't show any shorts in the output. Odd, right? I could take these out and double check them, but they show the same resistance values on this board versus a good board. So I know I'd say never assume, but based on readings, I assume the output is good. Usually when you have a bad output, you will see it in your resistance values. Sometimes you may have leaky gates, or not gates, I should say, leaky junctions. Transistors are about junctions. You could have leaky junctions, which can cause problems. So now we'll just flip this back over again, get everything back into view for you guys. So from here, before I apply power, I'm going to fire up my thermal camera. Because the thing about these JL boards is if there's an issue, really anywhere on the board, your transistors they're for sure 100% they are going to heat up. So you want to at least, you know, get yourself a thermal camera, a pretty decent one where you can see the image that you're trying to look at, to spot those problem areas before they become a problem, before you have to replace the parts. So I do have an old school FLIR TG 167 here. It's got a really funky firmware in this, because the picture's really super grainy at first, but if you snap a picture, delete the picture, the graininess goes away. So I'm just going to check over the transistors here. Nothing. I want a baseline here because I just got done soldering on these, so I want to make sure they're nice and cool. Yep. And what I'm going to do is I'm just going to check the temperature of the transistors. I'm just going to pulse the power supply. And we're looking good. The output transistors are not heating up. I did not notice if it was going to protect, guys. I was watching my thermal camera, so let's go ahead and check. I have a green light, and no yellow light, and no red light. So now, and again, the thermal camera showed that everything is good to go. And I do have thermal spots on the board, so that is telling me I am getting some regulated voltages. The power supply transistors are as cool as ever. Output are cool as ever. Now, let's see if we can get this to start swinging those transistors. I gotta set up all the switches correctly here. All right, so let's see. Let's go. Signal sense is off. Input sensitivity. Of course, we're gonna go everything counterclockwise. Full range. Gotta remember I'm looking at this board upside down. So all your dials and everything. All right, so signal sense is off, input sensitivity down, input level low, high. Mode slope off, input filter off, output mode, full out, full range. All right. So what I'm going to do is I'm going to start the amplifier up and see, do I have any gate switching? I sure do. So there's your gate switching right there for you. Nice, excellent switching on the gates. All right, so let me increase that voltage. I just want to check that other. Oh, that's rail voltage. Okay, we're looking good there. We're looking really good. Now the input. Right, the input section here, we're going to give it a 50 hertz signal at 2 volts input. This will tell me if the preamp section is going to agree with us. So I should see modulation in the gates here. Yep, and I do. So you'll see modulation. And when I mean modulation, you'll see the left-hand side of that signal become squiggly left to right. As that signal is modulating, you can kind of think of it as an up and down, but it's really left and right. It modulates that signal. And that going through the output filtering here will create that 50 hertz sine wave, because I'm putting in a 50 hertz signal on the scope here. So I should, if I can get in there, I should be able to see a 50 hertz output. Which, there you go, 50 hertz output. So just to recap on this board had a shorted output inductor, this inductor right here. A shorted output inductor. So one inductor is just fine. There's no signs of it overheating. This inductor, though, was completely destroyed. This output inductor overloaded the amplifier. It didn't short out the outputs. It overloaded the board to a point where your power supply transistors could not handle that load anymore. So of course they overheated. And as transistors heat up, you lose your current carrying capabilities. It's in every data sheet. You can pull up any transistor, JFET, MOSFET, HEXFET, PowerFET. You can pull up any of those and it'll give you a curve of output versus temperature. So as your amplifier increases in temperature, your overall power handling decreases quite dramatically too. Dramatically or drastically? Drastically, I should say. And then, especially when you're using the IRZ44s, don't get me wrong, they're still a good transistor, but they just don't have the current carrying capabilities of newer transistors, in my opinion, like the 3205s. These have been around forever also. So that's where this board ended up. Just an output or a power supply transistor failure, burnt the gate resistors, did not damage the drivers. As you can see right down here on the board, those drivers are still fantastic. 90% of the time when the power supply transistors fail, the gate resistors fail, and then all of a sudden your drive transistors will fail. And then you got to do a whole bunch of trace work here. It gets pretty in-depth on these JL boards. So that's what I did. I replaced the gate resistors, power supply transistors, replaced the output inductor, and these two, what were these? 224J 100 volt capacitors here, these little film caps. What is that? 10 to 20, that's 22 nanofarads? I would have to look at my capacitor chart. Honestly, guys, I have a capacitor chart on the wall right there because I don't have these things memorized. I'm really bad at memorizing things. I'm really bad at taking notes, again, as I said before. But that's all I replaced on this board. Output inductor, capacitors. Output transistors are fine. Rail voltage builds fine. Power supply builds fine. Power supply switching is fine. There's no ringing, no humming. So I feel this board is good to go back in the heatsink. So I do thank you guys for watching. If you have any questions, please feel free to leave them down in the comments. You'll catch me soon on a live stream. I do have four Orion 5,000 watt amplifiers that I got to get done. So maybe, just maybe, you'll catch me on a live stream. So thank you guys for watching. Stay safe. Keep your fingers out of the rail voltage. That'll give you a bad day. And we'll catch you on the next one. Thanks for watching.